A subset of natural number which has only two distinct factors. Only two distinct factors, that is 1 and itself. A number which has got only two distinct factor. Remember, only two. Otherwise, every number will have factors 1 and itself. A prime number is a natural number which has only two distinct factors. What are the two distinct factors? 1 and itself. The number which has only two distinct factors is called a prime number. A prime number series will be 2, 3, 5, 7 and so on. 2 is the only even prime number. The only prime number which is even, it is 2. 2 is the only even prime number. A prime number is a number which has got only two distinct factors. Suppose, for example, if I take 1, the natural number 1 has got only one factor, that is 1 itself. 1 into 1 is 1. Only one factor it has got. So 1 is neither prime nor composite. 1 is neither prime nor composite. Why? Because it has got only one factor, and the one factor is only 1. The number which has got exactly two distinct factors is called a prime number. 1 is neither prime nor composite. Next one. Every prime number greater than 3. If you observe, every prime number greater than 3, it is of the form 6k plus or minus 1. Depending upon the question, you can take anything. Every prime number greater than 2, it is of the greater than 3. It can also be of the form 3k plus or minus 1. 3 into 2 minus 1, 3 into 2 plus 1, like that you can generate your form. Every prime number greater than 3, greater than 2. Suppose, for example, if I take 2. Any prime number greater than 2, it is an odd number. Odd number can also be of the form 2k plus or minus 1 and 3k plus or minus 1. So, why to do any prime number other than 2, it is an odd number. Odd number is of the form 2k plus or minus 1. Any prime number greater than 3, 5, 7, 11, 13, 17, 19, it is of the form 3k plus or minus 1. So, in generic, we will use 6k plus or minus 1. In generic, we will use 6k plus or minus 1. 1 to 50, 15 prime numbers are there. 1 to 50, 15 prime numbers exist. And 51 to 100, 10 prime numbers exist. 1 to 50, 15 prime numbers, and 51 to 100, 10 prime numbers. Total 25 prime numbers are there from 1 to 100. This is also a very important key point. Now, based upon these key points, let us solve a lot of problems. Based upon this key point, we will solve a problem. This key point will solve a problem. Every prime number greater than 3, it is of the form 6k plus or minus 1. Vice versa may or may not be true. Vice versa may or may not be true. Vice versa may or may not be true. Right? 6k plus or minus 1. Now, let us solve the first problem. First problem, previous year examination question, model number 1. We will cover as per model, so it will be clear to you. There are 5 prime numbers. What are that 5 prime numbers? A, B, C, D and E. What is the condition? A less than, B less than, C less than, D less than E. 5 prime numbers are given, all are distinct. Now, he is saying A plus B plus C plus D plus E equivalent to 350. When I take prime numbers, now if I take case number 1, if all of them are odd numbers, let me see what will happen. If all the numbers are odd numbers, I am excluding the 2 case. If A, B, C, D are odd numbers, D is an odd number, B is an odd number, C is an odd number, D is an odd number, E is an odd number. You don't need to write it. Odd number of odd numbers is always an odd number. Odd plus odd, even. Odd plus odd, even. Plus odd. even plus even, even plus odd, odd. Right hand side should be an odd number, but the right hand side is an even number. So this case of all the 5 numbers, odd numbers, not possible. Case number 2. You cannot have more than one even number in the set of prime number. So the next case is, and the lowest prime number it is 2. So A is even, B, C, D, E. If it is odd, why only A should be even? Why? Because the lowest prime number which is even is 2. So these is nothing but A plus B plus C plus D plus E. Odd plus odd even, odd plus odd even, these even, even plus even, it is even. Right hand side it is an even number. This case is satisfied. The lowest prime number and even it is 2. So here the lowest is nothing but A. How many values of A power 5 are possible? A power 5, 2 power 5, 32. Only one value it is possible, and the value comes out to be 32. Very, very good question which talks about the application of the concept 2 is the only even prime. 2 is the only even prime. How to use this concept in finding the value of a variable? A plus B plus C plus D plus E, it is 350. Now if you see here, all of them are odd numbers, odd, 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 odd. Answer I will get odd. But in the question 350, it is an even number. One of them has to be even. What is the smallest prime number and even? 2. Question is 2 power 5, 32. Model number 1, it is clear. Next one. Model number 2. There are 4 values A, B, A minus B, A plus B. All are possible prime integers. Prime number is a subset of natural number. So all the values are greater than 0. A greater than 0. A greater than 0, B greater than 0, A minus B it is greater than 0, A plus B it is greater than 0, A minus B it is greater than 0, so A is greater than B. This is the hint we got from this word prime integers, A, B, A minus B, A plus B, all are prime integers. Now this point it is clear. Case number 1. Case number 1. Suppose if I take A and B as an even number, this will become even, this will become even, even minus even, even plus even, even. There cannot be more than one even number in the set of prime integers. This is not possible. Case number 1, it is out. Case number 2. A and B both are odd. Let me take both are odd numbers. A is an odd number, B is an odd number, odd minus odd even, odd plus odd even. There cannot be 2 even numbers in the set of prime numbers. Case number 3. Case number 3. A is greater than B. So you cannot take A odd, B A even and B odd, because the lowest prime number it is 2. So these is nothing but A odd and B is even, because any prime number greater than 2, it is an odd number. You cannot take A even, B odd, because there is not any even number which is a prime number greater than odd. After even only odd number will start in the set of prime numbers. A is odd, B is even. Only case is B is 2. A comma 2, A minus 2, and it is A plus 2. A comma 2, comma A minus 2, A plus 2. A is greater than B. Let us take A is greater than B. A prime number series will be 2, 3, 5 and so on. Any prime number greater than 3, it is of the form 6k plus or minus 1. So let me take 3 comma 2 comma 3 minus 2, 3 plus 2. 1 is neither prime nor composite. A is greater than B. Remember, after 2, the next immediate prime number it is 3. Next it is any prime number greater than 3. 6k plus or minus 1. Let me take 5. 5, comma 2, 5 minus 2, 5 minus 2, 3, 5 plus 2, 7, 5, comma 2, comma 3, comma 7. One quadruple we got. Suppose you take 5 is of the form 6 into 1 minus 1. Let me write down here. A, comma 2, A minus 2 and A plus 2. All are prime numbers. All are prime integers. All are prime integers. So we took A equivalent to 3. 3 comma 2 comma 3 minus 2, 3 plus 2. These are not possible. 1 is neither prime nor composite. Let me take 5. 5 comma 2 comma 5 minus 2, 3. 5 plus 2, 7. 5, 2, 3, 7. These all are prime numbers. 5 is of the form 6k minus 1. Let me take other numbers which are of the form 6k minus 1. 6k minus 1, comma 2. 6k minus 1 minus 2. 6k minus 1 plus 2. 6k minus 3. Divisible by 3, divisible by 3. Answer will be divisible by 3. So, there is no number other than 3 which is divisible by 3. Any prime number after 5, it could be 6 into 2 minus 1, 6 into 3 minus 1, 6 into 4 minus 1. There exists no prime number other than 5 which is of the form 6k minus 1, which will make these quadruple prime number A minus 2, 6k minus 3. It is divisible by 3. Next one, another case, 6k plus 1, 6k plus 1, comma 2. 6k plus 1 minus 2, 6k minus 1, 6k plus 1 plus 2, 6k plus 3, 6k divisible by 3, plus 3 divisible by 3, answer will be divisible by 3. So, the only case which is possible is 5, 2, 3, 7. What is B value? B value it is 2. What is A value? It is nothing but 5. Only value which will satisfy is B2 A5. But the question is, find the sum of all the 4 integers. 4 integers are 5, 2, 3, 7. Sum is nothing but 5 plus 2 plus 3 plus 7. 5 plus 2 plus 3 plus 7. I hope the idea it is clear. So, answer is nothing but 17. A is 5 and B is 2. 5 comma 2 comma 5 minus 2, 5 plus 2. 5 plus 5, 10, 10 plus 7, 17. How to find the values of A and B? Depending upon these statement, we got A is greater than B. A is greater than B. Definitely A will be an odd number and B will be an even number, because case number 1 and case number 2, it is out. I hope the idea it is clear. Each and every question, try to analyze it. Question number 2. Next, let us see question number 3. It is also a beautiful question, sir. Same model. Find the sum of all the positive integers for which 3n minus 4. Now a triplet is given. 3n minus 4. 4n minus 5. 5n minus 3. All are prime numbers. These all should be prime numbers. These all should be prime number. Case number 1. N is an odd number. Case number 1. N is an odd number. Case number 2. N can be an even number. N can be an odd number. N can be an even number. So, 3n minus 4. 3 is an odd number. Odd into odd, odd. 4 is an even number. Odd minus even is odd. Possible. 4n minus 5. These are nothing but 4n odd into even, even. Minus 5. 5 is an odd number. So, even minus odd, it is odd. 5n minus 3. It is odd. These 5n minus 3. It odd into odd, odd. Odd minus odd, even. Odd minus odd, even. I hope the idea it is clear. So, what is the only even number? 5n minus 3, it is 2. 5n equivalent to 5. N equivalent to 1. So, if I take the case of n as an odd number, Odd into odd, odd, odd minus even, odd. Odd into even, even, even minus odd, odd. Odd into odd, odd, odd minus odd, even. If I take n equivalent to 1, I am getting 3n minus 4. 3n minus 4. 3 ones are 3. 3 minus 4 minus 1. It is a negative number I am getting. But it is saying that all these numbers are prime numbers. Prime numbers are nothing but the numbers which are the subset of natural numbers. All should be positive. This case it is not possible. This case it is not possible. Case number 2. N is an even number. So if n is an even number, now if you see here, these 3n minus 4, 4n minus 5, 5n minus 3. N is an even number. Even into odd, even number. 4 is an even number. Even minus even, it is even. Even into even number, even. Even minus 5, it is an odd number. Even into 5, odd. These 3 is also an odd number. Odd, these even into even minus odd, it is odd. The only one case which we got is 3n minus 4 should be even. So if 3n minus 4 it is even, the case that is possible is 2. So 3n equivalent to 6. 3n equivalent to 6. N equivalent to 2. Check it out if n equivalent to 2, right? It is satisfying. 3 2s are 6, 6 minus 4, 2. Yes. 4 2s are 8, 8 minus 5, 3. Yes. 5 2s are 10, 10 minus 3, 7. 2, 3, 7. It is possible. I hope it is clear. I took two cases. N is an odd number. N is an even number. If I take an even number, for example, 4n minus 5, even into even, 5 is an odd number. Even minus odd, it is odd. Suppose if I take 4n minus 5, odd number if I take 1, 4n equivalent to 6, n will be in fraction. 4n minus 5, it is 8, n is nothing but 2. 8 minus 5, 3. This case it is possible. That is what I did. It is 5. 4n minus 5 is 5. N value 10 by 4. Not possible. Now if you see, 4n minus 5, it is 7. 4n equivalent to 12. N is 3. If n is 3, I am telling that n is an even number. Like that, further cases are not possible. Even, odd, odd. The only even number that is possible is 2. So 3n minus 4, it is 2. N value, it is nothing but 2. Very, very important variety of questions. In case if you are watching this video, after the video, kindly watch it again for effective learning. I hope the idea it is clear. Similarly, 5n minus 3, it is an odd number. If I take the lowest odd number 1, 5n equivalent to 4, n will be fraction. If I take 3, 5n will be 6, n is 6 by 5. Not possible. If it is 5, 5n equivalent to 8, 8 by 5. Not possible. 5n equivalent to 10, n equivalent to 2. That is what we did. 5 2s are 10, 10 minus 3, 7. Any other value, 7 we got, right? Next one, you might get these doubt, 9, 11, 13 and 15 and 17. 5n minus 3 is 17, n value 4. If n value, if it is 4, 3 4s are 12, 12 minus 4, 8. 8 is an even number, but it is not a prime number. All the three values should be a prime number. Very, very good questions, high quality questions we are going to discuss in the class. I hope the idea it is clear. Next one, oh, another good question, sir. Prime numbers, model number 3. Question number 3. Is 17 factorial minus 1 prime or a composite number? Wilson's theorem. By using Wilson's theorem, you can solve this question very, very fast. What is Wilson's theorem? If P is a prime number, Wilson's theorem is used. If the denominator, it is of the form prime number. Wilson's theorem is used to find the remainder when numerator is divided by a denominator. Denominator should be a prime number. Denominator should be a prime number. Now see, what is that concept? Reminder 1, p minus 1 factorial plus 1 when divided by p, it is 0. P is a prime number. It is 0 when p is a prime number. P minus 1 factorial plus 1 when divided by p, remainder is 0 when p is a prime number. Right? Now see here, based upon this one, you can take some examples. P is 5. These is nothing but 4 factorial plus 1, 24 plus 1, 25. 25 divided by 5. Remainder, it is nothing but 0. As long as the denominator is a prime number, p minus 1 factorial plus 1 when divided by p, remainder will be 0. This is Wilson's theorem. Wilson's theorem is used when the denominator, it is a prime number. There are some beautiful conclusions. There are some beautiful conclusions based on Wilson's theorem. First, it is remainder when p minus 1 factorial divided by p, it is p minus 1. When p, it is a prime number. When p is a prime number, p minus 1 factorial divided by p, it is p minus 1. Next one, remainder p minus 2 factorial divided by p, it is 1. When p is a prime number, p minus 2 factorial divided by p, remainder, it is 1. Third one, remainder 1, p minus 3 factorial divided by p, it is nothing but p minus 1 by 2. These are the three important conclusions from corollary's theorem. From Wilson's theorem, these are all the corollary of Wilson's theorem. Conclusions. In the previous class, I discussed the proof of each and every one. Go back and see previous classes of prime numbers. You will understanding why it came. The proof also I have seen. I have discussed by using backtracking. P minus 1 factorial by p, p minus 1. P minus 2 factorial by p, remainder is 1. P minus 3 factorial by p, p minus 1 by 2 when p is a prime number. Now see here, listen carefully. This question, 17 factorial, if I divide by 19, p minus 2 factorial by p, it is nothing but 1. So, remainder 17 factorial minus 1 divided by 19. 17 factorial by 19, it is 1. 1 minus 1, 0. That means answer is divisible by. Answer is divisible by 19. If it is divisible by 19, the answer will be a composite number. Answer will be a composite number. Very, very good question. It is. Once you understand the question, then the idea is very, very easy. This concept I used it. P minus 2 factorial divided by p, it is 1. 17 factorial by 19, it is 1. 1 minus 1, 0. Answer is divisible by 19. Please make a note of these three important conclusions. P minus 1 factorial by p, p minus 2 factorial by p, and p minus 3 factorial by p. Let us solve some more examples of this model so that it will be clear to you. Now, few more models. Is 51 factorial minus 1 prime or composite? Is 51 factorial minus 1 prime or composite? Immediately it should strike you. These p minus 2 factorial divided by p, it is nothing but 1. So, 53 minus 2. 51 factorial divided by 53, it is 1. 1 minus 1, 0. Answer is composite number. Answer, it is a composite number. Answer, it is a composite number. Suppose if it is 15 factorial minus 8 prime or composite. Is 15 factorial minus 8 prime or composite. 15 factorial, it is nothing but 15 into 14 and so on up to 1 minus 8. This is nothing but an even number. 8 is nothing but an even number. Even minus even, even. There is no even number other than 2, which is a prime number. Answer is composite. Answer is composite. I hope the idea it is clear. Answer is composite. Or you can also use 15 factorial by 17. 15 factorial. 15 factorial, this is the best method, sir. 15 factorial minus 8. 15 factorial contains 2. 8 is also 2. Answer is divisible by 2. What I thought of doing it is, just I wanted to tell you that 15 factorial contains 2, this contains 2, 15 factorial contains 4, this contains 4, 15 factorial contains 8, this also contains 8. Model number 3, Wilson's theorem application. I hope it is clear. Next one, another variety. Varieties of questions in our class is 20 factorial plus 21, prime or composite. What is the concept that we discussed? P minus 1, method 1. I will discuss this problem in 2 methods. P minus 1 factorial by P. It is P minus 1. P minus 1. So, this is nothing but 20 factorial by 23. 20 factorial by 23. These is nothing but these P minus 3 factorial let us take. So, these P minus 1 by 2. 23 minus 1, 11 by 2. These is nothing but 24 by 2, which is 12. So, if the question is like this, 20 factorial plus 11, it is not 20, it is 11, plus 11 prime or composite is 20 factorial plus 11 prime or composite. These giving remainder 12, these giving 11, 12 plus 11, 23. Answer is divisible by 23. Answer is divisible by 23. I hope it is clear. The best way of asking this question is like this. Which of the following? Which of the following? With 21 also, if you want, I will discuss. Which of the following divides? This is the best way of asking the question. 20 factorial plus 1. 23. 23, 21, 25, none of this. Which of the following divides 20 factorial plus 1? This is the best way of solving, because if I take 23, what I will do? I will get 20 factorial divided by 23, which is 12. 12 plus 11 is 23. So, answer is 23. 23 is perfectly divisible. This is the best way of asking the question. Otherwise, the question will become a cakewalk for you, sir. Which of the following divides 20 factorial plus 1? 20 factorial divided by 23. It is nothing but 22. Okay, this 22 by 2, which is 11. So, let us change the question is 12. These is nothing but 12. These is 11. I took it as 12. There is a calculation mistake. So, these is nothing but 11 plus 12 plus 11, which is nothing but 23. Answer is divisible by 23. I hope the idea it is clear. Let me change the question to these. These is nothing but, I hope you understood what is going on in my mind. These is 12. These is nothing but 11. 11 plus 12. Answer is divisible. You don't need to do all this. 20 factorial. 20 factorial is an even number. 12 is an even number. Even plus even is even. Answer will be divisible by even. Answer will be divisible by even. Please make a note of it. So, he might ask you a prime number which is just greater than this number. 20 factorial by 23, it is nothing but 11. 11 plus 12, it is 23. So this could be one way of doing it. Or if you see here, it is 21. 21 is 7 into 3. 7 into 3. 20 factorial contains 7 into 3. 12 is not divisible by 7 and 3. 25. Here 20 factorial contains 5, 10, 15, 20. It is divisible by 25. 12 is not divisible by 25. 21 cannot be the answer. 25 cannot be the answer. None of these three is right, but 23 it is right. So none is also eliminated. I hope the idea it is clear. Question is 20 factorial plus 12. In case if you want to use Wilson's theorem, you can use it. Otherwise, 20 factorial method number 2 into 19 into 18 and so on up to 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 21, it is 7 into 3. Now in 20 factorial, already 7 is present, already 3 is present. Answer 21 also has 7 and 3. So it is composite. Question could be anything, sir. Sometimes just by using the divisibility rule, just by seeing the divisibility rule, you will get the answer. Or if the divisibility rule is not giving you the answer, then apply Wilson's theorem whenever you are in trouble. Whenever you are in trouble. I hope you got the idea of how to check whether it is prime or composite. Another good question. 1x, x is a single non-zero digit. X is a single non-zero digit. Any number which is of the form 1x and x minus 1, whether this number is prime or composite. Now if you see here, prime or composite. Now there is a concept of divisibility rule of 37. Divisibility rule for 37. There are two concepts you should know. First one, remainder 10 cube divided by 37. 1000 divided by 37. This is nothing but 999 plus 1 when divided by 37. 999 is perfectly divisible by 37. So remainder it is 1. Remainder it is 1. So what is the concept? Start from right hand side. Start from right hand side. Take a group of 3 digits. Start from right hand side. Take a group of 3 digits. Add them. Take a group of 3 digits. Add them. This is the first key point. So take a group of 3 digits and add them. This is nothing but xx. X minus 1 plus 1. This is nothing but xxx. Third point, suppose if it is 111, x is written thrice, 111. 111, it is nothing but 3 into 37. 222, it is nothing 2 into 3 into 37. Any 3-digit number, any number which is of the form AAA, where single digit is written in groups of 3. If a single non-zero digit is written in groups of 3, if it is written in groups of 3, it is always divisible by which number? 37. Which is divisible by 37. Any number divisible by 37 other than 37, they are all composite numbers. I told you in session number 1, there are 237 ways to check whether a number is prime or composite. First one failing, go to the second one. Second one failing, go to the third one. All 237 fails, then the number is a prime number. Very good question, sir, which uses the concept of divisibility rule for 37. Every question, one new concept. Every question, one new way of looking at the question. Right? Divisibility rule for 37. 10 cube divided by 37, it is 1. Why? Because 37 into 27, this is nothing but 999. 37 into 27 is 999. 999 is perfectly divisible by 37. So, plus 1. Remainder, it is 1. So, start from right hand side. Take a group of 3 digits. Add them. So, x minus 1 plus 1. I got x. Any single digit written in groups of 3. It is always divisible by 37. It is always divisible by 37. Now, let us discuss one more question. Similar question. ABC. Is ABC prime or composite? Is ABC prime or composite? A 3-digit number is written twice. A 3-digit number is written twice. Now, another concept. Divisibility rule for 7, 11, 13. 7, 11, 13. Now, listen carefully, sir. Divisibility rule for 7, 11, 13. Reminder 1. 10 cube divided by 7. 7 ones are 7, 3. 3 cube 27 minus 1. Reminder 1. 10 cube divided by 11. 11 ones are 11 minus 1. It is minus 1. Reminder 1. 10 cube divided by 13. 13 ones are 13 minus 3. Minus 3 cube is minus 20. 6 minus 1 negative remainder. So, what is the concept? Start from right hand side. Start from right hand side. Take a group of 3 digits. Take a group of 3 digits. Take a group of 3 digits. Alternatively add and subtract. Alternatively add and subtract. If I do alternatively add and subtract, I will get the divisibility rule for 7, 11, 13. One example. Suppose if it is 112, 113 divided by 7. These are nothing but 112 into 10 cube plus 113 divided by 7. 10 cube by 7 is nothing but minus 1. 113 minus 112. Answer is nothing but 1. Answer is nothing but 1. Now see here. If I take a group of 3 digits, alternatively add and subtract. Plus minus ABC minus ABC. It is 0. That means this number is divisible by. That means this number is divisible by 7, 11, 13. Right? So, the answer is composite number. Proving that a number is composite is much more easier than proving whether a number is a prime number. I hope the another idea it is clear. Divisibility rule for 7, 11, 13. 10 cube divided by 7 minus 1. 10 cube divided by 11 minus 1. 10 cube divided by 13 minus 1. Start from right hand side, take a group of 3 digits, alternatively add and subtract. Alternatively add and subtract. There was a, these are all the questions are the previous year exam question. There used to be an examination, ATM. There used to be another examination, PGDCM. It is to do a computer aided management course in IIM Kolkata way back a decade before. These are all the questions which came from that examination. AB prime or composite. Another concept, divisibility rule. Divisibility rule for 101. If I take the divisibility rule for 101, these are nothing but remainder 10 square divided by 101. 100 divided by 101 minus 1. So, these are nothing but AB into 10 square plus AB divided by 101. 100 divided by 101 minus 1. Minus AB plus AB. What is the remainder? 0. So, what is the divisibility rule for 101? Start from right hand side. Start from right hand side. Take a group of 2 digits. Take a group of 2 digits. Alternatively add and subtract. Take a group of 2 digits. Alternatively add and subtract. If I do alternatively add and subtract, I will get the remainder when you divide a number by 101. So AB, these are nothing but AB into 10 square plus AB divided by 101 minus AB plus AB 0 plus AB 0. That means the answer is divisible by 101. So it is a composite number. It is a composite number. It is a composite number. Very important conclusion. AB plus minus, it is 0. If I write it 4 times, AB plus minus, it is also 0. Any 2-digit number written even number of times is always divisible by 101. I hope the idea it is clear. We will write that point. Note 2 important key points. We will write it. Any 2-digit number written even number of times, any 2-digit number written even number of times is always divisible by 101. So if the question is XY prime or composite, you can use this logic. XY. A 2-digit number written even number of times is always divisible by 101. Similarly, any 3-digit number, in the previous case also we can do. Any 3-digit number written even number of times, any 3-digit number written even number of times is always divisible by 7, 11, 13. For example, if the question is ABC, prime or composite, ABC, prime or composite, take a group of 3 digits, alternatively plus minus. So answer is divisible by 7, 11, 13. Please make a note of these 2 important concepts. A 2-digit number written even number of times is divisible by 101. Any 3-digit number written even number of times, it is also divisible by 7, 11, 13. I hope the idea it is clear. Next one, let x and y be a model number 4. Let x and y be positive integers. Okay. X is a prime number. X is a prime number. Y is a composite number. Y is a composite number. A prime number can be an even number or an odd number. A composite number can be an even number or an odd number. Now, first case, x is prime, y is composite, so I divided into even and odd. Even it has to be 2. The first case, y minus x cannot be an even integer. Suppose if I take x as 2, y as 4. Even number, right? Y minus x, 4 minus 2. 2 is an even integer. This is a false statement. Second one, x and y cannot be an even integer. X can be even 2. Y can also be even 2 into 2. Y can also be odd. In both the cases, I am getting an even integer. This is not possible. Next one, C. X plus y divided by x cannot be an even integer. X plus y divided by x. For example, suppose if x is 3, y is 9 divided by 3. This is nothing but 12 by 3. 12 by 3 is nothing but 4. 4 is an even integer. This cannot be true. Answer is none of the statement it is true. A previous year CAT question, sir. So here prime number means x can be even, x can be odd. Composite means it can be an even number, it can be an odd number. Here the only value it can take is even. Very easy question, sir. There is no much complication. Next, another variety of a question. N is a compositive integer. Root n is not an integer. Suppose let me take n equivalent to 12. N equivalent to 12. Suppose if I take 12, 12 can be written as a product of two factors, 1 into 12, 2 into 6, 3 into 4. It can also be written as a non-integer, root 12 into root 12. Root 12 into root 12, it is nothing but 12. So, if I write it like this, 1, 2, 3, root 12 lies between root 3, root 9 and root 16. Root 9 is 3, root 16 it is 4. So, 3 is root 9. These are nothing but root 12, 4, 6, 12. I am just writing like this because it will be useful in my question. 4, 12. Now, n is a composite integer. I took it as n value 12. So, 12 factors are 1, 2, 3, 4, 6, 12. I just inserted root n. N has a perfect integer valued divisor. For which it is greater than n, for which it is greater than 1 and less than root n. Are there any factors for the number greater than 1 and less than root 12 for 12? Yes, 2 is a factor of 12, 3 is a factor of 12. N has a perfect integer valued factor which is greater than 1. That means take all the integers greater than 12 and write down all the integers less than 12. In between you will find some numbers which will divide 12. That is what it is saying. Definitely greater than 12. Greater than 12 is nothing but 2 root 3. 2 into 1.7. Greater than 3.4. What are all the integers greater than 3.4? 4, 5, 6, 7, 8, 9, 10, 11. In that one 4 is a factor of 12. 6 is a factor of 12. So both the statements are right. I hope it is clear. If I take n equivalent to 12, 1 into 12, 2 into 6, 3 into 4, I will split it into root n into root n because the question is specifying about root n. 12, 1, 2, 3, root 12, 4, 6, 12. So, there are some factors less than root 12. Less than root 12 is 3.4. What are all the natural numbers less than 3.4? 1, 2, 3. In that less than 3.4, are there any integers which will divide 12? 2 will definitely divide 12. 3 will definitely divide 12. I hope the idea it is clear. A is true and B is true. Very, very good question. You can take any other example also. 18. 18 it is nothing but 1 into 18, 2 into 9, 3 into 6 and root 18 into root 18. Root 18 into root 18. 18 factors are 1, 2, 3, 6, 9, 18. I will insert one root 18. So, any integer less than root n, are there any factors for this number? Yes, root 18 is 3 root 2, less than 4.2. What are all the positive integers less than 4.2? 1, 2, 3. Some of the numbers will divide. Greater than root n and less than 18. So, greater than root n, which is nothing but greater than 4.2, 6 and 9 will divide. So, answer is both A and B are true. I hope the idea it is clear. Next one, another question. See here, the number of employees. This is again a cat level question. Number of employees in Obelix Mainir company is a prime number less than 100. Total number of employees, it is a prime number. This is the root cause of a problem. The ratio of the number of employees who are graduates and above and that of employees who are not graduates can possibly be. So, employees, total number of employees, it should be a prime number, and these employees are somebody are graduates and somebody are non-graduates. Somebody are graduates, somebody are non-graduates. Some should be a prime number. First one, 101 plus 88, which is 189. Which is 189. 189 if you observe 7 into 27. 7 2s are 14, 7 7s are 49. Answer is divisible by 7. It cannot be a prime number. 80 lowest I am taking 87k plus 100k, but we are taking k value 1. It is 187. 7 plus 1 8. Answer is divisible by 11. So these out. Next one. Third one, 110 plus 111, 110 plus 111, these 221, 221, we'll keep it aside. If we are getting 85 plus 98, these are nothing but 183, 183 is divisible by 3, sum of the digits it is divisible. Fifth one, 97 plus 84, which is nothing but 181. 181. So we are stuck in two numbers, 181 and 221. Which of the following it is a prime number? 181. Now, how to check whether a number is a prime number or not? For a smaller values we will do. So, three options we eliminated just like that. So, let us do one by one, 221 and 181. Now, please write down the logic. How to check? How to check whether a number is prime or composite? How to check whether a number is prime or composite? Now, listen carefully. How to check whether a number is prime or composite? If 36 it is there, what are all the factors of 36? 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, 9 is a factor, 12 is a factor, 18 is a factor, and 36 it is a factor. And 36 it is a factor. Now, root of 36 it is nothing but 6. So, put this in the box. Now, can I say these are all the factors less than root 10. These are all the factors less than root 10. Suppose if 36 is not divisible by 2, assume 36 is not divisible by 2. It cannot be divisible by 12, 18, 36. Or if an 36 is not divisible by 3, it cannot be divisible by any number which is a multiple. Can I say factors greater than root 10, factors greater than root 10 are actually multiples of factors less than root 10. Are you all with me? 9 is a multiple of 3, 12 is a multiple of 2 and 3, 18 is a multiple of 3 and 2, 36 is the nothing but 2 square into 3 square. That means if n is a natural number, write down root 10. All the factors less than root 10. All the factors greater than root 10, all the factors greater than root 10 are nothing but the multiples of the factors less than root 10. I hope the idea it is clear. That means greater than root 10. If the given number is not divisible by any factor less than root 10, automatically greater than root 10 will be dropped. If any natural number is not divisible by any factor less than root 10, so if it is not divisible by 3, 12 is out, 18 is out. I hope the idea it is clear. So we just eliminated first, second and fourth. Let us do the third one. Third one what we got? 110 plus 111 we got. This is nothing but 221. Let me take the square root of 221. 221. It is 15 point something. 15 point something. Now in 15 point something, what are all the prime numbers less than 15? 2, 3, 5, 7 and 11. Because every composite number can be written as a power of a prime number. 2, 3, 5, 7, 11. Is 221 divisible by 2? No. Divisible by 3? No. Divisible by 5? No. Divisible by 7? No. Divisible by 11? No. That means 221 it is a prime number. 221 it is a prime number. Let us do for the fifth one. 97 plus 84, which is nothing but 181. Root of 181. 14 square is 196. It is closer to 13. 13 to 14. Now if you see here, what are all the prime numbers less than 13? 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. Is 181 divisible by 2? No. 181 divisible by, I hope it is clear, right? 9, 181 only. 3, no. 5, no. 181, 7 2s are 14, 41, no. 11, 2 minus 8, it is no. So, we are not getting, what is the question? Ratio of the number of employees who are graduates and to above to that of employees who are not can possibly be. Possibly means it can be, it has to be a prime number. This is not a prime number. This is not a prime number. This is not a prime number. 110 plus 111. This is nothing but 221. 221 also we got a prime number. 97 and 84, which we got 181. 181. So 181, it is K. Next number is 362. The number of employees should be less than 300. 110 plus 111, it is 221. Next number is 442. That is also greater than. So let us see, we are getting two answer options. 189, it is not a prime number. 187, it is not a prime number. 85 plus 98, it is not a prime. 183, it is not a prime number. So we are stuck in these two. Let us see if there is any number that is possible. It is 221 and these is nothing but 181. It is, suppose if I take, suppose these is an 221. 221, it is an odd number. I am just cross checking if there is any other possibility. Odd into odd. These is also an odd number. Odd into odd. Let us see if there is any possibility. 1 into 1 is 1. Next one, 9 into 9 is 1. Next one, 3 into 7 is 1. These are all the unit digits. These are all the unit digits. Let us take, if it is 19 into 11, if I take, these are nothing but 11 nines are, it is 201. 201. So these are not possible. If I take 13 into 17, 17 threes are 51. It is 221. 221. Oh, it is. So these is nothing but root of 221. It is closer to 15. What are all the prime numbers? I think we have not taken 2, 3, 5, 7, 11. 13 we have not taken. That is the reason we got two answer options. Easily you can, if you are in doubt, you can actually go with this process. You cannot have two answer options. So that is the reason I just checked where I did a mistake. So answer is 221. It is a composite number. What I did? 221, it is an odd number. Odd number can be formed because of product of two odd numbers. 1 into 1, 1. 9 into 9, 81. 3 into 7, 21. So, these are nothing but 1 into 11 into 11, not possible. It is not divisible. 19 I took. It is 209. No. 13 into 17 I tried. I got 221. I hope the idea is clear. We forgot to take prime number 13. So in case if you are doing any calculation mistake, please go back and go through if you missed out any such number. This is a classical case where I took only the prime numbers less than 13, but actually we should include 13. Idea it is clear, right? Please take this question, sir. Try to solve this question. It's a beautiful question. This will be my first problem in the next session. This will be my first problem in the next session. Answer is nothing but 51. I wanted to know how you are going to solve this question. Take the screenshot of this question and solve it. I will solve this as the first problem. Idea is to tell you whether you are able to recognize the logic or in the simplest form. 2 by 4 and 1 by 2. 1 by 2 is in its simplest form. 2 by 4 is not in its simplest form. I hope the idea it is clear. 8 by 4, 2. 2 is in its simplest form. 8 by 4, it is not in its simplest form. Idea it's clear. This question we have already seen it. These also we have seen it. Next, p plus 14, p plus 26 are prime numbers. What is the concept that we are using? Any prime number greater than 3, it is of the form 6k plus or minus 1. Any prime number greater than 3, it is of the form 6k plus or minus 1. Numbers are p plus 14 and p plus 26. If p is 2 plus 14, 16, 2 plus 26, 28. 16 and 28 are even numbers, not possible. If it is 3, 17, 29, 3, 7, 29, possible. If it is 6k plus 1, these 6k plus 15, these 6k plus 27. These divisible by 3, not possible. 6k minus 1, 6k plus 13 and 6k plus 25. So 6k minus 1, if I take k plus 2 common, these 6a plus 1. If I take k plus 4 common, it is 6b plus 1. There are few prime numbers which are of the form 6k minus 1, which is giving me the other two numbers as prime numbers. For example, 17, 6 into 3 minus 1, 17 plus 14, 17 plus 26, 17, 31, 43, it is possible. If it is 83, 6 into 14 minus 1, 83 plus 14, 97, 83 plus 26, 109. There exists more than one prime numbers which will satisfy this triplet. This is the most repeated type in prime numbers, sir. Model number 7. More than one prime numbers possible. Not only p equivalent to 3, there exists some other prime numbers which are of the form 6k minus 1, which will also satisfy. There could be 2 numbers, there could be 3 numbers, 4 numbers, and so on. There is no limit for p. So 2 digits, 3 digits, 4 digits, and the process continues. I hope the idea it is clear. Next one, p plus 2. Again an exam model question. P plus 14 are prime numbers. So if p equivalent to 2 plus 2, 4, 2 plus 14, 16, it is not possible. If p equivalent to 3 plus 2, 5, 3 plus 14, 17, 3, 5, 17. These is a prime number triplet. Pythagoras is coming into my mind. 6k minus plus 1, 6k plus 1, 6k plus 3, 6k plus 15, divisible by 3. 6k plus 3, it is divisible by 3. These also divisible by 3. Not possible. P is 6k minus 1, 6k minus 1, 6k plus 1, 6k plus 13. 6k plus 13 is 6a plus 1. These 6k plus 1, these 6k minus 1. Again the same case. There are a lot of prime numbers which are of the form 6k minus 1, it is giving the answer. Let us see. If p equivalent to 17, 17 plus 2, 19, 17 plus 14, 31, 17, 19, 31. This is the case. Suppose if I take 29, 29 plus 2, 31, 29 plus 14, 43. These also another one. There exists more than one prime number which will satisfy this condition. Each and every question, kindly revise it as many times as possible so that this subtopic will be over. 6k minus 1, 6k plus 1 and 6a plus 1. I hope the idea it is clear. Next one. Another question. For how many prime positive integer, anyway prime integer will be positive, is p square plus 15p minus 1. This quadratic expression 15p minus 1, it should be a prime number. P square plus 15p minus 1. This should result in a prime number. This should result in a prime number. This is p. If p equivalent to 2, this will become 2 square plus 15 into 2 minus 1. 4 plus 30, 34 minus 1, 33. 33, it is a composite number. If P equivalent to 3, 3 square plus 15 into 3 minus 1, 9 plus 45 minus 1, 54 minus 1, 53. It is a prime number. 53, it is a prime number. Any prime number greater than 3, it is either 6k plus 1 or 6k minus 1. These 6k plus 1 whole square plus 15 into 6k plus 1 minus 1. Now listen carefully. 6k whole square divisible by 3. 2 into 6k divisible by 3. Divisible by 3. 15, it is divisible by 3. 1 minus 1 cancel. Answer is divisible by 3. Idea clear? Next one. 6k minus 1 whole square plus 15 into 6k minus 1 minus 1. 6k whole square divisible by 3. 2 into 6k divisible by 3. 15 into 6k divisible by 3. 15 divisible by 3. Plus 1 minus 1. Answer is divisible by 3. Any prime number greater than 3, it is of the form 6k plus 1 or 6k minus 1. Both are resulting in right hand side divisible by 3. So this cannot be, this cannot be. The value of P which will make this quadratic expression prime number, that is nothing but P equivalent to 3. How many prime values it can take? 1. This is the beauty about our classes. One subtopic, all the models will be cleared so that you will not find it difficult to write mock and therefore writing the CAT examination. Model number 7. This already we have signed this model because it's a previous year examination question. We can solve it. Q plus 4. Q plus 14. This triplet is a prime number. Q is 2. 2, 6, 16. 6 and 16 are even numbers. Not possible. Q is 3. 3, 7, 17. It is possible. Any prime number greater than 3. 6k plus 1 or 6k minus 1. So if you see these 6k plus 1, 6k plus 5 and 6k plus 15 divisible by 3, divisible by 3. This case not possible. 6k minus 1, 6k plus 3 and 6k plus 13 divisible by 3, divisible by 3. This case not possible. So how many values k can take? Only one value. Q equivalent to 3. Previous year questions are also over. Now it is P. P plus 6, P plus 12, P plus 18 and P plus 24. All these are prime numbers. If P equivalent to 2, 2 plus 6, 8, 14, 20 and 26. 8, 14, 20, 26. These are all even numbers. Other than 2, there is no number which is even. If it is 3, 3 plus 6, 9. 3 plus 12, 15, 3 plus 18, 21, 3 plus 24, 27. All are divisible by 3. So this also will not make it. If P is 6k plus 1, this is nothing but 6k plus 7. 6 into k plus 1 plus 1. 6k plus 13, it is 6 into k plus 2 plus 1. These 6 into k plus 3 plus 1. These 6 into k plus 4 plus 1. K plus 4 plus 1. Now see here. Listen carefully. 6k plus 1, 6 into k plus 1. Suppose if I put k value 1, this will become k value 1. If I see p value will become 7. 7 plus 18, 25. This case is not possible. If I put k equivalent to 2, 12 plus 1, 13. 13 plus 12, 25. This case not possible. If I put k equivalent to 3, 6 into 3, 18. 18 plus 1, 19. 19 plus 6, 25. Not possible. I hope the idea it is clear. K is 4. If I put k equivalent to 4, 25. It is not possible. K equivalent to 5. 31. 31 plus 24. It is not possible. I hope it is clear. So, when you divide a number by k, the possible quotients will be 1, 2, 3, 4 or 5. None of the cases it is possible. Next, let us take 6k minus 1. If I take 6k minus 1, these 6k plus 5, these nothing but 6k minus 1, 6k plus 5. It is nothing but 6k plus 11. These nothing but 6k plus 17. These nothing but 6k plus 23. If I put k equivalent to 1, 6 into 1 minus 1, 5. 5 plus 6, 11. 5 plus 12, 17. 5 plus 18, 23. 5 plus 24, 29. 5, 11, 7, 23, 29. All are satisfying. But if I keep k equivalent to 2, if I keep k equivalent to 2, so what it will happen? 6 into 2, 12. 12 minus 1, 11. It will become 11. This unit digit is 1. This unit digit is 4. Answer will be divisible by 5. These out. If I put k equivalent to 3. 6 into 3, 18. 18 minus 1, 17. 17 plus 18. 7 plus 8, 15. It is divisible by 3. Are you all with me? 6. If it is 4, 6 4s are 24 minus 1, 23. Unit digit 3 and it is 2. These also not possible. If k equivalent to 5, k equivalent to 5, 6 into 5, 30. 30 minus 1, 29. 29 plus 6, 9 plus 6, 5. So answer is divisible by 5. I hope the idea it is clear, right? I hope the idea it is clear. So answer is only one value, k equivalent to 1. I hope the idea it is clear. So this question, model number 7, all the questions are every prime number greater than 3. It is of the form 6k plus or minus 1. First problem in the next session. How to check whether a number is a prime number or not. There will be factors less than root 10 and there will be factors greater than root 10. Next one. These question we have already done it. X is a prime number, even and odd. X is a previous year CAT question, sir. How to check whether a number is a prime number or not? Divisibility rule for 7, 11, 13, 37. Divisibility rule for 101. By using Wilson's theorem, how to check? Or even and odd, how to check? How to find out the values, right, such that the given numbers are prime numbers by taking n even, n odd, n even, n odd. Sum of all odd number of odd numbers, it is always an odd number. These are the fundamentals. Again, we will have one more